start recording our lesson. And let's do some science. All right, gonna go here. If you guys remember, we are using a website called IXL.com. I think so far it's pretty fun. I think next week we're going to be starting a website called Mystery Science, which is one that's like more interactive for you guys, which I think will be more fun. This one's very educational, but Mystery Science I think is educational and fun, even though this one's like kind of fun. But yeah, we're gonna go ahead and get started. The rules from Tuesday still apply. All you guys have to do is I'm going to ask the class a question, and I would like you to raise your hand and give me your answer. And after that, after everyone has participated at least once, then you can participate as much as you want after that. I'm gonna check the chat box and hope that it's related to school, even though it doesn't seem like I can. Okay, I don't have IXL. Oh, we're going to leave now to do the work. Oh, okay, boys, that's fine. Thank you, Anas Ayubu. So good seeing you today. Okay, they are gone. Awesome. And Jay's coming in. Nishan, don't worry about that right now. We started IXL on Tuesday. You weren't here Tuesday, so I'll get you set up with that. Today. Oh, God bless. That was loud. All right. Philmon, what's your question real quick, and then we'll get started.
No, it's not a question. It's to answer the question.
Oh, well then just hold on. Jay, it's okay, buddy. Okay. Thank you, Philmon, for raising your hand. Try not to use the chat box today, because I want to see who's actually here. So I want you to raise your hand so I know you're here. That's why I'm making everyone participate at least once. So I know you're not just on and then you're like away playing games or away texting. I need to make sure that everyone is here, okay? Because technically I can only see Alexis and Philmon and Demaya anyways, and Jay. So everyone else, you could be lying or you could be here. I don't know. So that's why everyone's going to be required to participate at least once. Okay, let's go ahead and get started. Here we go. Mr. Warren poured 900 grams of cold tomato soup into a pot. He heated the pot on a hot stove. While the soup was on the stove, there was a change. As the soup warmed up, 100 grams of water in the soup vaporized. When Warren took his soup off the stove, the soup had a mass of 800 grams. Look at the graph, all right? So, cold soup, all right? And this was the hot soup, and then the evaporated water, okay? So, complete the following. Before the change, the mass of the cold soup was blank. After the change, the total of the hot soup and the water vapor was blank. Philmon.
900.
900. Awesome. And Philmon, what's this one?
900?
Yes. Good job. All right. That is correct because the soup total was 900. Then it became 800 because 100 of it evaporated, but it asked us to combine, so it stayed 900, but just in different groups this time. One was a gas and one was a liquid. All right, good job, Philmon. All right, Isabel gave her dog, Lola, a bath. When Lola was wet, she had a mass of 8 kilograms. Lola slowly dried off in the sun. After an hour, there had been a change. Lola had a mass of 7 kilograms. 1 kilogram of water evaporated from her fur. Mass before and after. So, wet dog, Lola. This is how much Lola weighed when she dried off. And then this is all the water that evaporated off of her. Before the change, the mass of the wet dog was blank. After the change, the total mass of the dry dog and the water vapor was blank. All right, J. No J?
The dog was 8 kilograms.
Okay.
Was it water vapor and the wet dog total?
It wants to know water vapor and the dry dog.
So the water vapor was 1 and the dry dog was 7.
So what do we get when we add it?
That's 8.
Good. That is correct. All right, these kind of sound like trick questions, guys, but they're pretty simple. So don't let them trick you up too much. I don't know why I don't know this stuff. That's okay. We'll figure it out together. That's why we're learning it. So don't worry. All right. Carmen took a 20-gram ice cube out of the freezer. She put the ice cube in a cup and covered the cup with a lid. She left the cup at room temperature for an hour. When she came back and saw there had been a change, the cup had water and ice in it. Now there was 10 grams of the ice cube and 10 grams of water because the ice cube started melting. Okay, so right here we have 20 grams of ice. Her ice cube weighed 20 grams, okay, which grams is less than pounds, so like, ice cubes are tiny. All right, then later she had 10 grams of ice and 10 grams of water because it started to melt. So before the change, the ice was blank. After the change, the mass of ice and water was blank. Wow, there's a lot of hands. Remember, okay, Alexis.
Before it was 20.
Yep.
After it was 20.
What was the after?
20.
20, yes. Good job. All right. Dr. Brady planned to use rubbing alcohol to clean her stethoscope. All right, stethoscope's that thing, the doctors use, boop, and then they're like, listening to your heartbeat and stuff. Okay, so she's cleaning it. She poured 15 grams of rubbing alcohol into a cup. She left it on the counter while she visited a patient. She came back a few hours later. There was a change. There were 10 grams of rubbing alcohol left in the cup. Some of it had evaporated. If you look here again, we have 15. She comes back, there's only 10 because 5 grams of it evaporated. All right, so before the change, it was how much? After the change, the rubbing alcohol and the vapor was what? All right, let's try and see people who. Anusha.
15.
All right, and then how much was the alcohol and the evaporated at the end?
5.
5 plus what?
15.
So the answer is 15, but yes, so it would be 5 plus the 10 that was left. Good job. All right, guys, we are already on step 2. Okay, got to get 4 right in a row. We got this. Gavin made a pot of hot apple cider. He poured 200 grams of apple cider mix into a pot with, go away. Okay, with 700 grams of water. He put the pot on a hot stove. The mixture warmed up and began to boil. After 20 minutes, there had been a change. Some of the water evaporated. The rest of the water had mixed with the apple cider to make 800 grams of apple cider. Oh, go away. Okay, to make 800 grams of apple cider. Complete the bar graph below. So, hopefully we're paying attention. All right, she had her apple cider mix that she poured into the water. All right, and then she had a hot apple cider at the end, and it was 800. So now, how much of it evaporated? I have to click where it evaporated. So I need someone to tell me by raising their hand, where am I putting this? How much water vapor is in the air now? Draven.
800.
You think it's 800?
Yeah.
All right, let's see if that's right. So that is not correct, because with our apple cider and our water, we have 700 and 200. That equals 900. This gave us 800 of cider. So 900 minus 800 would have been 100. All right? So in total, if we just mixed it and didn't boil it, it would have been 900. But because it said we were left with 800, we know 100 of it evaporated. Okay? Hey, good guess. There we go. Look right here. 200 plus 700 equals 800 plus blank. All right? Not bad. Okay? This one's new. This one's different, but we got this, okay? Okay. Ernest had an 800-gram ball of wet clay. He rolled out the clay to make a thin, flat plate. Overnight, there was a change. Some of the water in the clay evaporated and formed water vapor. The next day, Ernest's plate was hard and dry. It had a mass of 600 grams. Complete the chart. So guys, I like this one because it's artistic, but we have wet clay, and I made a plate with it. The next day, my plate is hard. It's ready to like be a plate, but it's only 600 grams. So it got lighter because the water in the clay evaporated. So how much water vapor is there now that evaporated from this? I've already caught Kabir. Oh,
200.
yes. Good job, buddy. It is 200 because 800 minus 600 is 200. Awesome. All right. Luther filled a water jug with 2 kilograms of water and some ice. He closed the lid and took the jug to the park. There, he left the jug on a picnic table for a few hours. When Luther checked on the water jug, he noticed a change. All the ice had melted. There are now 2.5 kilograms of water in the jug. Complete the bar graph. So he puts all this water in his jug, and then he puts ice in the jug. By the time he gets to the park, the ice melted, and there's 2.5 kilograms of water. So how much ice did he originally have? I see Agni's hand. I haven't called on you yet. Agni, how much ice did he have? Are you putting it in the chat?
0.5?
0.5. That is correct. Good job. All right. Sorry, let me check. Chat. Why does the chat never pull up for me? Oh my gosh, you guys are funny. Okay. Miss Roy put a bottle with 150 grams of salad dressing into her refrigerator. Her salad dressing was made of oil and vinegar. After a week, she took the bottle out of the fridge and saw that there had been a change. The oil and vinegar had separated. There were 125 grams of oil and some vinegar. Complete the chart. So she has salad dressing. Combining oil and vinegar is a very popular salad dressing. All right, so this is her salad dressing. After how much? A week, it started to separate. So the oil usually, rises, and then the vinegar would sink, and then there was 125 grams of oil. So how much vinegar would be by itself now? Niraj.
25.
25 is correct. Good job. All right. Zach poured water into an empty 25-gram ice cube tray. He covered the tray, put it in his freezer. That night, Zach took the tray out of the freezer and uncovered it. He saw there was a change. The tray was filled with ice cubes. The total mass of the tray and the ice cubes was 225 grams. Whoa. Complete the bar graph to show the mass of the water. Man. All right, guys. So this little tray, this little empty tray, was only 25 grams. He put water into the tray to make ice cubes, which is normal. And then when he's done, the tray and the ice cubes both weigh 225 grams. That's a lot. So essentially, how much water did he pour in there? How much water went in? Stella.
200.
Yes, 200 grams of water. Good job. All right, guys, we're on stage 3. This one is multiple choice. So we have to answer 3 questions correct, or sorry, 6. I cannot read. I was reading that. We have to answer 6 questions correctly. I still, based on students, I have 1, 2, 3, 4, just 4. 4 of you have not participated at all yet. All right, which means only 2 questions will be open to the whole class. But I still need to hear from Lalita, Nishan, Demaya, and I think Portia, right?
I don't even know how to do this.
That's okay, we're gonna do it together. All right, I would rather you try than just not participate. All right, so Lalita, Nishan, Demaya, Portia, these next 4 are for you guys. All right. Kyra set a cold, closed, 70-gram bottle of apple juice on the counter. The bottle had a mass, which means it weighed 30 grams, and then the juice weighed 40 grams. So as we know, 30 plus 40 is 70, okay? All right, a few minutes later, she noticed there were many small drops of water on the outside of the bottle. The total mass of the water drops. The bottle of apple juice was 75 grams, all right? If you guys have ever seen this, when you have a very cold drink and the cold drink starts to get a little warm, you know, all those water drops on the side is like the ice and the condensation melting. So which statement explains the change? There was water vapor in the air. Water vapor condensed onto the cold apple juice bottle. Some of the apple juice evaporated and then came onto the outside of the bottle, or there was water in the apple juice. As the bottle of apple juice warmed up, some of this water leaked through the glass. All right? Demaya.
A.
Yes. And guys, why it's A, just so everyone knows, and you can test this if you want, just make sure your cup is clean. Your drink will never evaporate and go on the outside. You can't have apple juice that evaporates and then lick your cup on the outside and taste apple juice. That'll never happen. Also, there's water in the apple juice and then the water leaks out. If the water was leaking out and that's how the water got on the outside, that would mean there's a bunch of holes in your cup, like a bunch of tiny holes, and that's just not true. So Demaya is correct. There's water vapor in the air, and then because the drink's cooling down, the water vapor attaches itself to the cup because it likes the cold, it likes the ice. So yes, Demaya is correct. All right. Oh, we got another chart. Sweet. All right, Kyra just closed her 30-gram bottle on the counter. The bottle had 40 grams of apple juice again. The water vapor condensed on the outside. All right, after a few minutes, there were water drops. Oh, so this is the exact same thing. Together, it was 75 grams. All right, so guys, this is the same question, but this time we're doing it in graph form. So we have her bottle. We have her apple juice. Whoa, sorry. We have her apple juice. We also have, after her bottle, her apple juice, which stayed the same, and then the water, All right? So, to show the mass of the water vapor. So, how much water vapor was there around that cup to produce the water on the outside? Lalita.
35,
You said 25?
45.
35?
Yeah.
All right. Does anybody think maybe it's something else, Agni?
Hello.
Is it 0?
What?
Did you say it's 0?
What?
Agni, your hand is up, so I called on you.
I forgot to lower my hand.
Okay. All right. That's fair. Portia.
Uh, 45.
We think it's 45?
Yeah.
All right. So we think it's 45. Someone else thinks it's 35. All right. So let's find out what the answer is. So, guys, we have the mass before and after. So the water vapor is actually still 5 grams. The only difference is that the water went from vapor on like in the air around the cup and it attached to the cup and then started to turn into those water droplets that we see. Okay? So, as you guys know, water is H2O, hydrogen, and then 2 oxygen. Since it takes 2 oxygen and all the air is surrounded with oxygen, when you have a very cold drink, you can't really see it, but you can already see, if you were here, there's already some condensation starting on the cup, on my Chick-fil-A cup. Because the already air around here is starting to attach itself to the cold, starting to attach itself. And then it just gets bigger and bigger and bigger as it melts. I don't know if that helps at all. But we can go down here and then it explains it some. 30 plus 40 plus blank equals 30 plus 40 plus 5. So it would have to be 5. All right. If that helps at all. Conservation of matter to find the mass of the water vapor. The mass of the bottle, the juice, and the vapor before the change is equal to the bottle, the juice, and the water. All right. Matter can change in many different ways. It can be mixed with other matter. It can also be heated or cooled. Sometimes heating or cooling causes matter to change state. Water is the best example of this because if you freeze water, it becomes as solid as ice. But if you heat up water, it becomes vapor or a gas. All right. So as the water starts to melt or cool down, or warm up, sorry, that's why you start to see that. Yeah. All right. Here we go. Next one. Janice made a sandcastle at the beach. She mixed 100 grams of seawater with 400 grams of sand to make 500-gram mixture. She used the mixture to build a sandcastle. Which statement, when Janice was done, her sandcastle had a mass of 450 grams. Some sand was stuck to her hand. All right. Which statement explains the change? All right. The sandcastle is made of sand and seawater. Most of the sand and seawater is in the sandcastle, but some of it's on Janice's hand. The sand was cool when it lay on the beach, then warmed up in the sun, so it lost mass. All of the sand and seawater Janice started with is in the sandcastle. The sand on her hand is from somewhere else on the beach. All right. So this one's going to be a little tricky. If you read it one more time, she mixed 100 grams of seawater with 400 grams of sand. The sculpture was 500 grams, but then it lost 50 grams at the end because some of the sand was stuck to her hand, is what it specifically told us. Okay? So, which statement explains what changed? Film on.
B?
Did you say B? You said B, right?
Yeah.
Okay. Is that true? It is not, because in this instance, when it lost 450, it said, it didn't tell us any time had passed. It just said when she was done, it was 450. So we know that those 50 grams that lost had to be on her hands. If it said time had passed, if it said that she waited and came back, then Philmon would be right. It would have totally been B, because if you wait and then come back to your sculpture, it is going to dry. It is going to dry, and then that means water vapor is going to evaporate. So Philmon would have been right. However, it didn't tell us any time passed. It said just when she was done. So like right away. That's why. So that's the only reason why it's A. Otherwise, if time passed, Philmon would have been 100% correct. Okay? So, Philmon, you were like half right. Okay? So don't be discouraged because your train of thought was correct. Okay. Miss Kirby made an omelet in a pan. She mixed 3 50-gram eggs with 75 grams of milk and 25 grams of cheese for a total of 250 grams. She covered the pan with a lid and put it in a hot stove. After a few minutes, she saw the omelet was cooked and it weighed 225 grams. There were many water droplets on the inside of the pan lid. If you've ever cooked something on the stove and put a lid on it and then you open it, see a bunch of water droplets on the top and then like a bunch of steam comes out. Okay? So it's 250, now it's 225. So which of these is true or explains it? There was water vapor in the air on outside of the pan. The water vapor condensed to form water droplets. The eggs, milk, cheese gained thermal energy as they were heated. So they gained mass. There was some water in the eggs, milk, and cheese. When the omelet cooked, the water vaporized, then it condensed on the pan's lid. All right? We already know it's not B because we had 250 and it went to 225, so it lost weight. And B says it gained weight, so we know it's not B. So it has to be A or C. Who knows which one it is, though? Is Portia's your hand still up? Or Kabir, which one is it?
A.
Think it's A? Let us find out. It was not A. Fascinating. So, water vapor on the outside of the pan. This water vapor condensed to form water on the inside of the pan. So, the reason why it was not A is because we cannot take water from the outside of the pan and put it inside the pan. It's not going to work. The reason why that worked on our cup is because there's already water vapor outside in the air we breathe. Just there always is. That's why it could be on the outside of the cup. But this time, the water vapor was on the inside of the pan, which means there had to be some water in there at some point for the water to go in. I hope that makes sense. Hopefully. All right. All right. We probably won't finish today because we're gonna be done here in like 5 minutes because then I have a few announcements. So we might not finish this, but that's okay. All right. Bridget went for a walk in the rain, and one of her 600-gram rain boots got covered in mud. To clean her rain boot, Bridget washed it in a bucket with 800 grams of water. After a few seconds, Bridget noticed a change. Her 600-gram rain boot was clean. The bucket was filled with 1,000 grams of muddy water. So right here, her rain boot was 600. The water she put with the rain boot was 800. When it was done, her rain boot was fine, but now we have all this muddy water. So how much mud got mixed with the 800 of water? Nishan.
200.
200 is correct. Good job. Lee made a piñata. He cut 150 grams of newspaper into strips. He dipped each newspaper strip in glue and arranged the strips to form a piñata. He used 500 grams of glue, so together the newspaper and glue had a mass or weight of 200 grams. Lee let it dry for a few hours. When it was dry, it was only 175 grams, so it lost weight. What explains this? The newspaper absorbed the glue, so the glue lost mass. The newspaper was cut into small pieces, so the mass of the strips was less than the mass of the newspaper. There was water in the glue. The glue lost mass when some of the water evaporated. All right? Hint, it cannot be B. If you have a newspaper and then you cut it up into a bunch of pieces, as long as you have all the pieces, it weighs the exact same. If you have Mr. Hughes and you chop off my arm, but you weigh me and my chopped off arm, I'm still gonna weigh the same, okay? Don't chop off my arm though. Okay, all right? So it has to be A or C. Do we think the newspaper absorbed glue, or do we think there was water in the glue that evaporated? Nishan. Oh no, Draven, sorry, Draven. I haven't called on him yet.
A.
A, the newspaper absorbed the glue, so the glue lost mass.
Yeah.
All right. Does anybody agree with him? I can't see everybody. Can you guys see everybody? Okay. Who thinks it's C then? Got one person. Just one? So one person thinks it's C, one person thinks it's A, and everybody else died. Right? You're all dead. Oh, see, there we go. Kabir answered. Thank you, Kabir. Philmon and Draven and Kabir, thank you for answering and participating. So I'm gonna say the same thing for B. If the newspaper absorbed the glue, and the glue is still inside the newspaper, the glue's weight doesn't actually change. The glue's weight didn't change, but the only thing that could have changed should be water. And I was gonna say, if I'm wrong, you guys can all laugh at me, but I was not. Ha ha ha. Okay. So the piñata dried, some water vapor evaporated, okay? The finished piñata was 175. So the newspaper, 150, glue, 50, piñata, 175. So how much water vapor evaporated from that glue? Niraj.
I'm pretty sure it's about 50.
You're close.
25.
Yes, it would be 25. Good job. All right. So guys, it is pretty much 11:45. Excuse me. I'm gonna go ahead and stop just so I can do some announcements. I'm gonna go ahead and end